Welcome to another Base Electronics Beginner's Guide.
Workbook. Yeah, you're here with myself, Shigi, and also with Crow. Crow's going to be doing the reading today. I'm going to be fumbling around on the no solder board. And yeah, thanks for joining us, for everybody that's joining us. Feel free to jump in chat. We turned one of our monitors around so we can actually read chat a little bit nowadays. And
it's a helpful evolution.
Helpful evolution. Yeah, we learn a little bit more as we go.
Absolutely.
Not just about electronics. Cool. All right. So where did we leave off?
All right, so we just ran a bunch of tests on our secondary board. So now we're going to go ahead and look at resistors.
Resistors.
All right. So here we are. Resistors. As you've probably noticed, we have had quite a journey with resistors, trying to figure out the color coding, make sure that we had the right ones, trying to decipher. It's been a journey.
Yeah, I don't know how colorblind people. I still think this is unfair to colorblind people. I'm just saying.
Anyway, so yeah, it really does seem like it might be not for the colorblind.
Also, I love that they printed in black and white, and then they're talking about the colors. It's like, okay, cool.
Very helpful, because orange and brown
look exactly the same. Brown and black look exactly the same. I don't know how they do this.
Yeah, they say red, orange, and brown means, and you're like, oh, that's all the same on blue.
Yeah.
Oh, we're going to find out. It's going to be fun. All right. So, to begin, resistors and how to use them. Resistors resist the flow of electrical current. They have many uses. You will learn how to use resistors to reduce current flow and measure voltage. The unit of resistance is the ohm. If a current of 1 ampere at the voltage of 1 volt flows through a wire, the wire has a resistance of 1 ohm. So to repeat that, a current of 1 ampere at a voltage of 1 volt flows through a wire. The wire has a resistance of 1 ohm.
Now, is that because the amps that are going through it?
That's what it sounds like.
Okay.
Yeah.
All right.
So that's the equation there. That's pretty useful to know, actually.
Yeah. I'm sure we're gonna blow a shit ton of wires, just so you know.
Absolutely.
I'm putting that out there now. I'll put money on it that we start at least 1 or 2 fires on accident.
Yeah. Oh man. Or just blow one of our capacitors. Yep.
Oh yeah. That's why we got a whole box.
Absolutely. So, the resistor's color code. Our friend. A resistor's resistance is indicated by 4 or 5 colored bands or rings. A 4-band resistor, is the one as you see on the left. The 4th band there gives the tolerance. Gold is equal to a plus or minus of 5%, silver plus or minus of 10%. An example of this would be a yellow-violet, red-gold is 47 times 100 or 4,700 ohms. Gold means the actual resistance is within 5% of this.
Oh, okay.
So now when we were reading the resistors, you can actually check and see how much it's going to resist looking at just the colors.
Just the colors. Okay. That makes a lot of sense.
That's really crazy, actually.
There's no way I'm going to remember that. I imagine we'll probably accidentally end up remembering all of these as we start going through.
I would actually like to, give that a good try, because I do like codes and stuff.
Sounds like some cards, some of those study cards. We're going to have to put them in there and start practicing.
Just have it in the middle of the page. Oh, what resistor is this one?
Brownie points.
And the 5-band resistor, which is a more specialized resistor, the 5th band gives the tolerance red, and it equals 2%. For example, red, brown, gray, brown, red is 218 times 10, or 2,180 ohms. Red means this actual resistance is within 2% of this.
Okay.
So if you're really looking for, like when we did that timer, for the blinking LED, We could change the speed of it using different resistors or a different size capacitor. And in this case, we can control that a lot more precisely. So if we're looking for like
I don't think was it the speed, or was it the volt, like the light, like how much went into it?
I think the resistor slowed the current into the capacitor, and then the capacitor would discharge once it was full.
Oh, because we had that 555, and that was the timer one, right?
It was yeah.
Okay, all right, it's all coming together.
Yep.
It's been a minute since we did that one.
Group of loops. Tip, by the way, use K for 1,000 and M for 1 million.
Yeah.
4.7K is 4,700 ohms. 1 M is 1 million ohms.
Got it.
Ohm's law and resistance. Ohm's law lets you find the voltage V across a resistor, the current I following through it, or the resistor's resistance R in ohms. If you know two of these three values, here are the formulas. V is equal to I x R, I is equal to V divided by R, and R is equal to V divided by I. Well, that's actually really cool. So
okay, so it's just either the volts and the amps tell you the ohms, or ohms and it's just okay. All three of them just basically play together.
Yeah, and that's really cool because when again going back to that timer, the clock that we made for that LED light blinking.
Yeah, it did. It played a part.
It absolutely did.
Okay, makes sense.
And we'll be able to use these equations to make our own versions of that.
Right. Hell yeah.
Absolutely. Hell yeah. All right. So we're going to build a circuit to measure resistance. Oh, that's awesome.
All right.
Cool. So the first thing we're going to do...
Turn it off.
Absolutely. Step
I remember
one.
that one. We're going to turn it off.
That should be our screen.
Turn it off?
Yep. Remember.
Step one, turn it off.
Absolutely. Step 2, insert a 10K or 10,000 ohm resistor across springs 2 and 64.
Got it.
It
and
says
we're
borrow.
cheating. We're cheating for everybody that's watching. We actually went and got these guys, so now we don't have to worry about the colors. They're labeled for us. We just got to make sure we put them back in the right spot. All right, 10K.
Okay.
10K, where are we going with it?
Springs 2 and 64. It says borrowed. I'm not sure what that means.
2 and 64. All right. Springs 2.
Oh, okay.
And 64. Okay, I was really worried about how much room we were supposed to have in these guys.
Same. I thought last time we were all down here. So.
All right, cool.
Okay,
good.
excellent.
I should probably lift that guy up a little bit. Put in the springs here a little higher. Okay, we should be good.
Okay.
All right.
So we're going to take a blue wire and connect to spring 1 to the ground.
All right, blue wire. Spring 1 to ground. I don't think we're using blue wire unless we got longer one. Oh wait, where's our? We need a bunch of longer ones. We lose those guys, or are they up there?
Oh, they're up here.
Let's take it out of the tester lab.
Yeah.
Oh, I did find one blue one.
Rocket.
All right, so blue wire.
As always,
spring 1.
Gotta go to the toolbox.
All right. Yeah, there's going to be at no point during any type of preparation are we going to be able to have everything that we need. Even regardless if we spent hours doing it, we always need to go grab something.
Absolutely. All
All right, what else we got?
All right, so now we gotta connect a yellow wire to spring 64.
All right.
That's it.
That's it?
That's it.
Where's the yellow wire go?
Spring 64.
That's just spring 64?
Yep, spring 64.
Okay.
Absolutely. All right, so we're going to use this to test the circuit. Important, by the way.
Yeah.
Be sure to use a 10K resistor. Less resistance might damage the meter. Push the power switch on and connect the free end of the yellow wire to V3.
All right.
For 4.5 volts.
So I'm turning it on.
Okay.
4.5 volts.
And what do we get?
Oh, cool.
Excellent.
It shot up. The milliamp shot up to 4.5. The little meter over here.
Yeah. The meter looks like we're at about 0.42.
Yeah, we're about
yeah.
4. Yeah, it's about right. Well, 4.5. Or, I'm sorry, 0.5, but I can see it.
Yeah, that's
cool.
really cool, actually.
All
so,
right.
that's 0.4 milliamps, by the way. So, that's 0.00042 amps.
Okay.
If you're learning labs batteries are fresh, so that's how much you're going to get for using fresh batteries. That's probably why we're getting a higher readout, because we're
because we got brand new ones.
Yeah, probably.
Yeah, okay. All right.
If your learning labs batteries are fresh, as I said accidentally, oops, from Ohm's law, the resistance is 10,714 ohms, 4.5 volts divided by 0.00042 amps. This is within 7% of specified resistance. What is your result? Oh, okay.
We're at 0.5.
So now it looks like the resistance is a 10K. We're at 4.45. So now if we were to do the equation, 10,000 divided by the 0.00045, we'd probably get some indication. Is this a 4-band resistor or a 3-band resistor?
Or a 5-band?
Or that's what I meant.
Five.
It's a 5-band. And it's supposed to be within 2%?
I don't think that's within 2%. Let me try something. That's like 0.5, bro. Correct me if I'm wrong. Maybe I'm just looking at it weird.
No, I think you're doing pretty good. That's just under. I would say 4.7, 4.8.
Yeah.
Yeah, so 10,000 divided by 0.00048.
0.00048.
20,000.
No, that's way more than that.
Oh boy, that's a little bit.
I think we're doing math wrong here.
Oh, I am wrong. You are correct. We gotta do the volts. That's what our equation's for.
Okay, so let's figure this out.
About more than just circuitry.
Yeah, it's about apparently busting out your phone and pulling out a calculator.
Yeah.
All right, where are we at? What are we doing?
All right, so we use the 4.5 volts.
Okay.
So now we gotta divide the 4.5 volts by the amps.
Okay. So it's volts. So 4.5.
Yep.
Divided by 10,000.
0.00048.
0.00048.
Correct.
Where did we get in that 48?
That's 9,007.
That's because of where we just came from.
Absolutely.
Okay, and then that pulls up the 9,374, which is indicative to our resistor, which is the 10K.
Yeah.
Okay. This is all starting to make sense.
That is really crazy.
And then it's supposed to be within what?
Well, with a 5-band, we're supposed to be within 2%.
It's probably about 2%, right?
Oh, that's more math.
It's like 9.4
divided by 10,000.
Well, I'm not doing it. I'm just gonna assume that we're in the right spot. I'm saying that's like 9.4 out of the we're expecting a 10.
So that's about 6%.
Yeah. So it's still out of range. Maybe these resistors are just shit. I did buy them from Amazon. They ship from probably somewhere. Okay, well that's good to know.
That is really interesting, actually.
It's good to know. All right, cool. Unless that was 4.7 and not 4.8.
Anyone get the answer before we did?
I seriously doubt it. They're busting out their calculator like these idiots don't know what they're doing. We've also been drinking, so you have to bear with us. That's how it works.
That's why we always gotta make sure that circuit board is off every time.
Oh shit! Yeah. So the circuit board's off now.
It is. Hell yeah.
All right. Cool.
Excellent. All right. So I mean, we can do a bunch of others if you want.
Yeah. Let's keep rolling. Let's do some more.
So Ohm's law and current. Current is measured in amperes. Ohm's law shows that the current I through a circuit equals the voltage V across the circuit, divided by the circuit's resistance R in ohms. That's what we
Yep.
should have just read on, man. Or I equals V divided by R. Some parts, like light-emitting diodes, LEDs, are damaged by excessive current. Resistors are used to limit, reduce that current. And I think that's actually controlled by the color that you need out of the LED, too.
Oh,
So I
right,
think
yeah.
some colors are... That was actually, I think, a real big problem with making red LEDs.
What, just like trying to like get the right amount of current going into it?
Yeah.
Does it have like require a higher one, do you think? Or like a lower one?
I think it has to really reduce the temperature of the light. So I think it goes down. I think you have to make it like resist it like a lot.
Makes
to get
sense
that
to
color.
me. I don't know if it's right, but it makes
Yeah.
sense to me. We'll see.
That's why engineers do this. That's why they call it mechanical engineering, not mechanical hobbying.
Electrical engineering in this case.
And absolutely.
Yeah.
See, not electrical hobby.
Not electrical hobby.
Not for us.
For us it is. All right.
Absolutely.
What else do we got?
All right, so the next circuit we're going to build is one that shows how resistance reduces current. So we're going to go ahead and get 3 new resistors.
Okay. What do we
A
need?
1.5K.
Do we need 10K again?
It does not look like we will.
All right, I'm putting that back so we don't lose these.
Yes.
All right. 10K is back in the box. We need a 1.5. Okay.
Okay. A 3.3K.
Put these in order. 1.5. And do a 3.3. All right.
A 6.8.
6.8.
And for you guys following along at home, that is a brown, green, and red, an orange, orange, and red, and a blue, gray, and red. Good luck.
Seriously, dude. Actually, these ones aren't too bad.
They're not from the 90s, that's why.
Yeah, I think that's it. That's what happens when you use something that is older than the store that sold it. Yeah, these are actually not bad.
Holy smokes. Nice.
Cool.
See?
All right. I think we're ready to roll. What are we doing?
First thing we're doing is switching the thing off.
It's off.
Second thing we're doing is installing R1 across spring 4/6 and ground.
All right. Let me take these off. Doing R1, resistor 1, which is the
1.5K.
1.5.
And that's coming from our push buttons.
1.5 is the brown, black.
That is a brown, green, and red.
Oh, 1.5.
1.5K.
Here we go. Brown, green, black, red. No. Okay, never mind. I take it back. Oh, there it is. Brown, green, black, brown, brown. Got it. Okay.
Oh, okay.
That's our 5. All right, and we are hitting where?
4/6 and ground by the push buttons.
46 and ground. Gotcha. Got it.
And it looks like our next one is going to be receiver 2, the 3.3K. Orange, orange, red.
And in this case, it's orange, orange, black, brown, brown. And that matches up to our box here. Okay.
Excellent. And that is spring 4/8 and ground.
48 and ground. Okay, so we're going to have 2 different switches
Actually,
to this
3.
guy.
We have 3 is actually. So the next one's
Oh, we're going to do the same thing to the third?
Mm-hmm.
All right.
It's going to spring 5/0 and ground.
Gotcha. Now, it doesn't mention which way this is supposed to go.
Yeah, that's pretty
Is it
interesting.
like bi-directional? Does it not matter?
Yeah,
we'll
it doesn't
find out.
say anything. Every indication seems to show that, there's an order to reading the colors. I wonder if that's the order the
Well, we'll find out because these two are facing in the one direction because there's like a fatter end to it, and then this one I had put the other way. So if this one doesn't work, then we know that it's not bi-directional.
And if you look on this, the bands are closer on the left, and that's where the electricity is flowing from and flowing into.
Gotcha. Okay.
So I think it does come from left to right according to the colors.
All right, we'll figure it out. I mean, let's see if we can get it not to work.
Yeah, that'd be nice.
Or catch fire.
Absolutely. We're going to connect springs 4.7 and 4.9 with a white wire.
Okay. Oh, these are just giant wires. You gotta have some smaller ones here. There we go. What are we doing?
We're going from
4.7 to 4.9?
4.7 to 4.9
All right.
and 4.9 to 5.1 with a white one as well.
4.9. Oh, we should probably turn them so they're out of the way. 4.7 to 4.9, and gotta have another one of these little white guys in here. Yep, sure do. Oh, it's a little bigger. There's a small one.
Just so you guys can follow along with what we're doing. I apologize. So I get caught up in that circuit board sometimes.
All right, 4.9 and 5.1. Got it.
All right.
And I don't, even though it's mashed up in here, I don't see anything touching. Those are shielded wires. We should be okay.
Rocking. Next one up is a blue wire. Springs 5.1 and 1.
Got it.
Spring 1.
Is it spring one? All right, spring one's all the way up here.
Springs 5.1 and 1.
One's our little
okay.
milliampere. What is this? Milliampere? Milliampere? I can't pronounce this. Milliampere? Milliamperes?
Milliampere.
Milliamperes. All right.
Seems.
Sounds good.
Yeah, I like that. Milliampere.
Milliamperes.
It's one of the Musketeers.
The fifth one that they
Yes.
never included in any of the movies.
So it's too hard to say his name. Last but not least, connecting spring 2 to V1.
I figured. Yellow wire?
That is a yellow wire to 1.5 volts.
It's not a lot of volts.
Really is not. No.
All right.
All right. So.
And we did all that without keeping the board on by accident, so I'm very impressed.
Absolutely. Yeah. Holy smokes. Testing the circuit. Important. Be sure that no resistor is less than 1.5K. Too low resistance might damage the meter. Push the power switch on and press S1 to connect the smallest resistor between the power supply and the meter.
All right. Turned it on. No fire yet. I'm going to press S1. Whoa.
Wow, yeah, that goes pretty good.
All right, it went all the way up to 1.
The meter will indicate about 0.88 mA.
0.88. That was more closer to like 0.99. So,
all right.
Okay.
Sure. Excellent. Well, we're going to press S2.
We're like, all right, anyways, we're going to move past that one.
Well,
S2?
let's take a look. Do you want to take a look? We can
No,
see.
no, I don't think there's anything touching. I don't know what it is. I tried tweaking this a little bit, but I don't think this is going to do anything. I think what's happened is... There we go. Let's see. Oh, I did that without turning off the board. You know what? It's a little wobbly. I don't think it's like getting hammered. I think we're still off in that little percentage here.
Yeah. Well, let's try S2. See, it says it should indicate about 0.42
All right.
milliamperes.
If history tells me anything, I'm gonna say it's 0.5.
Yeah, I'm with you.
And we're at 0.5.
Oh my God, almost right on target.
All right.
And last but not least, S3. The meter will indicate about 0.19.
All right, it's going to say 0.3. Oh, man, I'm good. So something is off. But it's off consecutively.
Yes.
So I think that threshold that we were talking about is about, this might be standard. Maybe it's just like the resistors we got. It could be anything, but this might be well within our threshold that we're trying to operate in, so I'm kind of here for that.
Yeah, actually, and if we did need to find out how badly we are off, we could always
What happens if I press both of them?
well, let's find out.
Well, hold on. Okay.
So,
Oh, shit.
interesting.
All right. So it goes, this is about like 0.2, I don't know, 2.5. So 0.25, right? And if I press this one alone, it's about 4.5. So if I press both of them, it adds them.
Yeah.
It adds them. Okay. Cool.
And that's probably what was happening in that very first circuit we made.
Before, yeah, with the
Yep.
yeah, okay,
And so by the time we get to the end,
that makes sense.
yep.
All right, cool. I'm gonna turn it off before I do that again because I definitely pressed S1 in all three of them.
Oh,
I'm sure I
boy.
didn't want to break that.
Yes. We definitely don't want to send too much through there, for sure. Ohm's law and voltage. Oh, yeah. Some people saying hi. Hello.
Hello. Hi, Violet.
On the Abyss Sands.
Abyss Sands, nice,
Excellent.
awesome. Welcome.
Ohm's
Thank
law.
you for tolerating us.
Absolutely. Ohm's law and voltage. Just moving on, man.
Moving on. Let's just move past it, bro. Let's
Just move past
let's
it.
just go through it.
Voltage is measured in volts. Ohm's law shows that the voltage V across a circuit equals the circuit's resistance R times the current I through the circuit, or V equals I times R. The current meter on your learning lab can be used to measure 0 to 10 volts if you connect a 10,000 ohm resistor in series with it. Okay. That's pretty interesting. So we're going to build a voltmeter and a circuit that measures that voltmeter, or that voltage.
Okay, let's do it.
We're going to need that 10K resistor again.
Okay.
Excellent.
That's why I put it back where it came from.
Absolutely.
Wait, so we're pulling these apart, right?
Yep, we're going to go ahead and tear that down.
All right, which was R1?
R1 was 1.5K.
Got it. All right, I'm going to see if I can actually figure out these color codes just as we go.
I'll pull these out
1.5?
and just throw them on the tail for you.
Pull 'em. All right. Brown, brown, black, orange, orange. So if I do that in reverse, orange, orange, black, brown, brown, that's going to be our 3.3. Is that right? The second one?
Our second one is 3.3.
All right.
Absolutely.
And our third one here, I'm going blue, gold, black, brown, brown. Is that right?
Blue, gray, and red.
Gray. Okay, that's a bit gold looking. Is that 6.8?
That is 6.8. Absolutely.
All right.
6,800 ohms.
Got it. Let's pull these wires out of here. Ugh. Get out.
Oh, yeah.
We're done.
That's right.
Get out of my face.
Go away.
10K. Let's go.
Absolutely.
All right, where's that guy going?
Well, after we push the power switch to off, we're going to insert R1 across spring 64 and 2.
It's
I just
off.
gotta say.
I know. I
Step
feel
one.
you.
Step one.
You said 61 and
64 and
64.
2.
64 and 2.
64 and 2.
Oh, up here at the top.
Oh, okay.
All right. Back up here. That's, oh, wait a minute. 64 is a photoresistor.
Huh.
Okay. All right, let's just keep going.
Yeah. That's pretty interesting. Maybe they just needed to resist somewhere on the line.
Well, that should be for the light, right? So, like, we could block this and it will do something. All right.
Yeah,
let's
that's interesting.
Let's build it and then we'll figure it out.
Connect spring 1 to ground, blue wire.
Blue wire, spring 1 to ground.
And then an open yellow to 64. And that'll be our test.
To 64,
To 64.
not to 65.
64, that is correct.
Okay. Weird. Okay.
Cool. All right. Yeah, that's. We're just gonna.
I'm not going to touch it.
At this point, it's halfway magic. We're working our way through the
It's
book.
mostly magic still, man. Magic and math now.
Yeah, yes. The second type of magic. Make sure that R1 is a 10K resistor.
It
Then-
is a 10K resistor.
Awesome. Then push the power switch on. Imagine that the numbers on the meter scale have no decimal points and that they indicate 0 to 10 volts. Now connect the free end of the yellow probe wire to the 1.5 volts.
Okay.
It'll indicate to us about 1.4.
Yeah, we got about 1.8.
Okay. The table shows the voltage.
Oh, wait, 1.4?
1.4. So it is saying that.
Oh, wait. I know why. It's because we're now basically, we've got the 10K resistor set up. So this changes even though this is 0 to 1, it's like, it could be, depending on the resistor, it could be 1K, or it could be
Okay, yeah.
out of a scale of 10,000, or it could be a scale out of like a mil.
So
This makes sense. See what I'm saying? Because it depends on the resistance that we're pumping through it.
Yeah, actually.
Okay, this makes a lot of sense now.
And what I like too is that they just use that circuit as a circuit. You know, we don't need when we're making like breadboards and stuff, seeing things like using circuits that are open just to be able to pass the signal through them is
Just
pretty.
to kick it.
Yeah.
Which is like a voltmeter, right? That's basically what the whole point of it is. They're open ends, so you can just kind of like tap into where it's at.
Yeah, exactly.
That makes a lot of sense. Okay.
Well, excellent. We can test the next groups.
Okay. What are we doing? Turn it off.
No, it says with it still on if you want to test the other volts.
All right. So that's supposed to be 1.5.
So it looks like we're going to be
That
up.
pops us up to like 3.
Okay, so that should be...
This,
next, the V2 is 3.
this is like 5.
4.5, 5, yeah.
This is going to be... Oh, that one's dead on. That's 6.
Nice.
5 is V7, which basically puts us about there. And then we have the 9 volts, which should stop just shy of the 1, which it's dead on 9.
Excellent.
So you know what I've noticed? It's really just... It's like our 3 volts.
So it
It's
seems
a little
like...
larger.
Yeah, it seems like we might be getting uneven power through these.
Well, I mean, this thing was made when I was... This thing was built when I was like 12 years old. This is cool, though. This makes a lot of sense.
It is super cool.
All right, cool.
Well, so it does tell us that with fresh batteries, we will be getting about 6 to 7% difference in some of these.
Okay.
We'll be trying to reduce that error using the next set of tests.
Cool.
So,
How much time you got left, bud?
well, it is just about on the money.
You got to call it?
Well, let's take a peek at what the next page has for us. We're going to build a better voltmeter. Why don't we do that? Why don't we build another and better voltmeter, and then next we can use resistors to divide the voltage.
You want to do it now, or you want to do it next time?
Oh, we can do the voltmeter now for
Oh,
sure.
All right, I'm with it. I'm trying to be respectful for your time. I know we had some
appreciate it.
audio issues, so.
Yeah. Yeah.
All right, cool. I am ripping everything apart.
So we're going to be doing a better, more advanced, probably even with AI this time.
With AI.
Yeah, look, this page here
Yeah.
is written by actual intelligence.
You're saying somebody who knows what the fuck they're doing is what you're saying. It's not really artificial. It's just experience at that point.
All right, so building a better one. We are
do it.
going to need a gray, red, red resistor.
It's not helpful because of the. These are 5.
That's true. We are going to be looking at 8.2K.
8.2K.
And we're also going to want to keep that 10K.
Okay, well I put the 10K back. 8.2K.
Yeah, it looks like we're going to be putting the 8.2 in the middle of our circuit between the other resistor and where our voltmeter is.
To be honest, it looks like we ain't putting it fucking anywhere because we don't have an 8.2.
8.2, 6.8.
6.8 to 10K. No 8.2s. We're hunting. I think we have to go hunting.
Okay, you might be right. Oh, man. I was saying if we can maybe make an 8.2, but if the 1.5 and 6.8 is going to make an 8.3.
What? What's up?
6.8 and 1.5 is going to make it 8.3.
Why don't we just use a 6.8? YOLO.
Yes.
All right. We're doing a 6.8 instead of the 8. Let's do it that way.
Yeah, I wish, I wonder if we do have them, but yeah, we'll get the part out.
Yeah, we might. Honestly, oh, you're right. We have the entire.
We have this.
Here, I'll go through our filing cabinet of resistors here.
Back to the toolbox.
Let's see. We're looking for an 8.2.
I believe so. Yes.
Yeah. Okay. Well, according to this, there's 10 of them in here. So.
Rocking.
All right.
I'll take a ream.
That's our 10. Here's your half.
All right.
Here's my half. We're looking for 8.2.
Every good workshop has a toolbox you run to, and you can't find a piece.
Still, every time I go through these, I feel like I'm looking at like a Pokemon deck.
Gosh, yeah.
18. 3. 12. I think it's in yours. Oh, wait. That's either 8.2 or that's 82,000.
Let's see. Oh, 8200 is 8.2. So we're going to be looking at a gray, red, red. Does that look like it might be a gray, red, red on there?
This says 5 bands.
Damn.
Yeah.
Okay, here's an 8.2.
Oh.
Exactly.
Oh, well then that's it. Then this is 82K.
And this is a 5 band? Oh, but remember, it does tell us what a 5 band would look like at an 8.2 as well.
Does it?
Yes, it does. And that looks like, that looks like it would have to be some math of some kind.
All right, we got it. Let's move on. I want to build things, man.
Absolutely.
I'm not mathing today.
All right, so our last voltmeter was off by about 6 to 7% of an error. We saw that in our smaller voltages.
Yep.
Once we got up to higher voltages, seems like our batteries are able to overcome that error. Probably something with the resistor. That's why we're learning this.
I wonder if it's just like a loss, like an expected loss based off of like what you're putting in. So I'm wondering if you're just like, if you're feeding it less, like volts, it might be like a wider range of it being off. You know what I mean?
Oh yes, yeah.
Could be. I don't know. Who knows?
It's mechanics that move that dial as well, so maybe.
That's true. All right, so we have the 10K. Excuse me.
And the 8.2.
The 8.2 right here.
All right, and our power is off.
Power is off.
Power's off. Okay, so R1 is our 8.2.
All right. So I got the 8.2. Where are we going with it?
I am confused. So when we're looking here, okay, so we're at our first R1 is going from 37 to 38.
Okay.
That's 64 to 2, but it's not showing us that up here.
So that's a... Oh. It looks like our first volts are going from into R2, and then that's feeding in... R2 is going into R1. And then that goes into our meter. So it's the volts to 38 and 37 to 64.
Okay.
I don't know. Let's figure it out.
Yeah.
What's the steps?
So the first step is to push the power switch to off. Insert R1 across springs 64 and 2. R1 is our 8.2.
64
and 2.
and 2. Oh, you know what I just remembered? I had them in different ways, It looks like we had no issues originally, right?
Oh.
I forgot about that. So they seem to be bi-directional. I don't know if that's
Okay.
standard or we just got away with it. So we'll have to figure that out. That's going to be a takeaway.
Yeah, you know what? That's actually something we can figure out. Just, swapping
Turn it
around and then
See
then
if it changes
testing
it.
the volts and
I like it.
absolutely. So, our third step, more like, spring 1 to ground with the blue wire.
All right. Oh, the blue wire. Okay. So closing it out there. Got it.
Okay, connect springs 6-4 and 3-7 with the yellow wire.
6, 4, 3, 7. So we're going back into our photoresistor. 64 to what?
3-7.
37. Oh.
So that's an interesting
Okay.
thing because it tells us that to connect the yellow wire to spring 38, and that is we're connecting a yellow wire to just spring 38. That's
Okay.
That's probably gonna be our test.
That's our test.
So
wire.
R2 is
We
our
got another
potentiometer. Oh,
We got another yellow somewhere?
yellow.
No, we don't. I'm going to do green.
Okay.
We're going to do green. Green, so that's going to 38. All right, this is our testing.
Yep.
Are we missing a resistor?
We
need
are
that
not
10K.
actually.
Why did they need the 10K?
That is our 10K resistor, a potentiometer.
Oh.
Potentiometer.
Shit. Okay,
Yeah.
so you have the potential. I'm assuming this is just like a thing that allows us to like scope it up to a max of 10K.
That's what I'm kind of thinking. Yeah.
So we don't need to use these shits anymore eventually. That'd be great.
That would be awesome.
All right, cool. All right, so I think we're good to go.
All right. Time to test. Time to turn the thing on. I think.
Turn it on.
Make sure that R1
No
is an
fire.
8.2K resistor.
It is an
Again.
8.2.
Imagine the numbers on the meter scale have no decimal points, and that they indicate 0 to 10 volts. Connect the free end of the yellow probe wire to to the 6 volts.
Oh, it just told us our answer. We were right. It said don't imagine there is no decimal points, and it just goes from 0 to 10K.
Yeah.
It told us our answer. We figured it out, thankfully, but like I think it told us our answer too. Cool. All right. What am I doing? Connected it to?
6. That's 6 volts.
All right. We're getting 7.
All right. So it looks like at 6 volts, we should actually be getting it right on the money.
Oh, shit.
Oh, dial it in? What? Okay.
That's why.
Then adjust the console potentiometer until the meter needles point to exactly 6 volts. Connect the probe wire to each voltage point, while watching the meter.
All right, so that's 6.
So we should be seeing on everything outside of 6 an error of 0.1.
Okay, so I'm gonna go to 7.5.
Okay.
That looks about right. So that would basically be 7,500, right?
Yeah, that's 7.4
And we're off,
in here.
we're off a little bit. All right.
We should be getting 7.4 on there. That's what it should be reading to be proper.
That's probably about right.
Excellent. Oh, man.
And then we'll switch over to 9.
9 is actually going to read 9.
It's
the
reading
only
9.
other one.
3, 9. All right. What if we kick it down to like 1.5? We should. Yeah. See, we're like 1.7 there.
Okay.
Oh, I'm sorry. 100 and. I'm saying 1 point because I'm looking at 1.5 volts, but
No,
we're at 170.
we actually you are reading it correct. We would have to be at 1.4 according to this chart, but 1.7.
Okay.
So, yeah, I think it would be 17 maybe.
That's a little over 3. 4.5 is a little over as well.
So that's
6
interesting.
volts is dead on. You know what I think it is? It's got to be this board.
Yeah.
It's got to be these three. They get a little bit more juice for some reason.
That's okay. Once we learn more about this wiring, we might actually be able to fix that.
Yeah, they are pretty low in voltage though. So
Yeah. That would be really interesting actually to get in there and fix that thing knowing what we know.
I wonder if the other one does it.
That would be an interesting, well, you know, we have a few moments.
Do you want me to create one real quick?
Yeah, what,
All right.
let's go ahead and get this thing.
I think you're good actually. We don't even need to turn it on. See if it does anything. Nope. All right, cool. I'll rebuild this guy over there. I don't think we're using any of the current existing pieces, so we should be good.
Yeah.
All right, so
I'll just quickly remake that circuit over here. We could probably just use these wires. We got just 3 wires and then resistor.
yeah. All right.
Too easy.
2 to 64.
Oh man, next we gotta be building what? A voltage divider? We're gonna be doing math with this thing.
Oh man.
Oh man. Nah,
I
man.
didn't sign up for math, dude. I signed up for drinking and most likely setting something on fire on accident.
Imagine all the rest of the kids in class are using their calculators, getting in trouble by a teacher, and this kid comes in with a voltmeter. What are you doing? Push different things. Oh, nothing. Doing math.
No, we're running it through this for some reason.
I think it's just to connect the circuit because it's the closest spring.
Oh, okay. Yeah, that makes a lot of sense because I did not understand why we were doing that.
Yeah, me either. That's what I was thinking. It's interesting that you can kind of sort of look at these not as stations, but
I wonder
as
if that was
pins.
it. Like, what happens if we covered that? I'm gonna try it on this guy.
Now that would be interesting.
All right. So let's take this, put that into 6 volts, and we'll turn it on.
There it is.
And
Bam.
We're basically
Dial it in.
dead on.
Yeah.
All right. Now
Let's go pop ours over to that 1 because I think that was the biggest difference, wasn't it? It was like
Yeah.
1.9 or 1.7.
it's a little closer.
Okay.
But now I'm curious. I'm gonna. No, nothing. Okay, and that's
Okay.
because it's not part of it.
It's not a full
That makes
circuit
sense.
there. I really like
3
how
volts, dead on. There's something wrong with that board.
Okay.
4.5. It's a little short.
And see, this is really cool, but
6 is on.
for all you guys watching at home,
7.5 is a little high.
we essentially
Nine's dead
just
on.
use the technology that they gave us, the book that they gave us, and we're able to diagnose problems just like this.
Yeah, it's pretty cool.
Learning what we are learning.
I
This is really
learned.
cool. Yeah,
I learned good.
and practical application. That's really cool.
All right, cool. I have removed all of the pieces that we just put into our little tester board that
Yeah.
we built from earlier. I'm going to keep that one off to the side, though. But, yeah, cool. That makes sense. Awesome.
That is really cool.
All right. Are we going to call it? What do you think?
Yeah, I think our next
Oh,
our
shit.
next set is gonna be a bunch of new things.
I never turned the board off. All right, cool. All right, well, thank you everybody for hanging with us for a little bit. Sorry we started a little late today. We're having some issues with OBS. If anybody is a streamer, you understand exactly what the hell we're going through. And as always, thank you for hanging with us, and hopefully we'll catch you in the next one. Next Monday around 5:30.
Yeah, but sounds good. Same
Yeah.
time, same place.
And if you're interested, we upload these to our YouTube channel. You can scan that QR code. That'll bring you to our LinkTree. YouTube should be in there. Or you could just search for YouTube, look for our Hackerspace BitHaven, and the series is the RadioShack No Solder Workbooks. And if you want to catch up, or if you're joining us for the first time, definitely check that out. Get caught up. We by no means understand or know any of this. We're stumbling through it, and we really appreciate your patience. And for everybody that's been, commenting and watching and going along with us, thank you. Hopefully we'll have more. Hopefully we'll all be a little bit smarter at the end of it. And as always, we will see you in the next one.
And I do definitely hope we don't start any fires with these things.
And no fires. And always, 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 first step Turn off.
Turn off. Yep. Step one.
Turn off. Have a good one, everybody.